Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Let's find the LCM, or least common multiple, of two rational expressions. So to find the LCM of two or more expressions, we want to factor the expressions completely. The LCM is the product of the highest power of each factor that appears in any of the expressions. All right, so we're going to do two examples, and let's walk through this process together. So example number one, we have 6x squared minus 54 and 9x squared minus 54x plus 81. So let's factor each of these expressions separately and see what we get. So I noticed for 6x squared minus 54, we could factor out a 6, and that's going to give me x squared minus 9. Now for 6, right, that would be 2 times 3, 1 times 6, right, whatever we need to have. Let's just write it as 2 times 3, okay? Now, x squared minus 9, I noticed that is what we call the difference of two squares, right? So that's going to factor as x plus 3 and x minus 3. Okay, so we've got number one factored, or we've got 6x squared minus 54 factored. Now let's factor the trinomial. So here we have a quadratic trinomial where a is not 1, but the good news about this one is that a, being 9, is a factor of b and c, so we could just factor the 9 out. So we factor out the 9 and we get x squared minus 6x plus 9. And hopefully you notice, well, we'll get to that in just a second. 9, we could write that as 3 squared, right? So there's that factor. And x squared minus 6x plus 9, this is a trinomial, but it is a perfect square trinomial, right? So this would be x minus 3 quantity squared. So now we have both of our expressions factored. So now let's think about the LCM. So notice that it said the LCM is the product of the highest power of each factor that appears in any of the expressions. So we have a factor of a 2 here, so we need to write that down. Then we have a 3, but here we have a 3 squared, right? So we're going to go with 3 squared. And we have an x plus 3, so we need to add that. And we have an x minus 3, but here we have an x minus 3 quantity squared, so we're going to go with the one that is squared. So x minus 3 quantity squared. Now we can simplify this a little bit. So 3 squared would be 9, 9 times 2 would be 18, and we can write our other two binomials next to 18 just like this. So our LCM for these two expressions would be 18 times x plus 3 times x minus 3 quantity squared. Okay, let's do one more. So example number 2, we have 9x squared minus 16 and 3x squared plus x minus 4. So if we look at the binomial, okay, let's factor out a 9. Well, that doesn't work because 9 is not a factor of 16. But if you'll notice, this actually is the difference of two squares. So if we look at 9, we could rewrite this as 3x squared, right? And 4 squared would be 16. So 3x squared would be 9x squared, right? And so now we have the difference of two squares, so we would write this as 3x plus 4 times 3x minus 4. Okay, so we're done with that expression. Now let's get down to the next one. So we have a trinomial and a is not 1. Can we factor out 3? No, we can't. So we have to use some other method in order to factor this trinomial. So I prefer to use what's called the x method. It does involve a little bit more work to be shown, but I have found that you're going to limit the number of mistakes you might make if you use this way. Now, you're in Algebra 2 or higher, and so at this point, you might be able to just use your head to figure out how to factor this, but for the purpose of this video, I'm going to show you what this x method looks like, and if you want a little bit more in-depth video about the x method, I'll link it in the cards right now. So what the x method is going to tell me to do is, number one, I'm going to draw an x over here, and up here I'm going to write a times c, and down here I'm going to write b. So a times c would be negative 12, 3 times negative 4, and b would be 1 because I just have an x there in the middle. So now over here on these sides, I want to think about what multiplies to negative 12 and adds to 1. So hopefully we're thinking of 4 and negative 3. Okay, so now I'm going to use those two numbers and I'm going to replace the x in that original trinomial to create what we call a 4-term polynomial. So now I would have 3x squared minus 3x plus 4x minus 4. And notice we didn't change the value here because if I were to combine my x terms in the middle, negative 3x plus 4x would just be x, right? So now I'm going to group my first two terms and my last two terms, and I'm going to factor out the greatest common factor. So for 3x squared minus 3x, we can factor out a 3x, and that would give us x minus 1. For 4x minus 4, let's factor out a 4, and we also get x minus 1. So now the purpose of factoring using the x method and using grouping is so that we get a common binomial now that we could factor out, which would be x minus 1. So now we could write this as x minus 1 times 3x plus 4. Okay, so now we see our two expressions completely factored, and so now let's think about our least common multiple. So we have a 3x plus 4 in both of our expressions, but they both have just it's just one term of those, right? It's not being squared, so we're going to write 3x plus 4. Now we have a 3x minus 4, so we need to include that, and we also have an x minus 1. Okay, so this would be our LCM for number 2. All right, and that's how you can find the least common multiple of two rational expressions.